All right. So, hi. I actually did my hair and I want proof on video that I did my hair and I got out of my pajamas today. But just thought I'd throw that out there so we can all say congratulations, Mrs. Cornelius. Very proud of you. Thank you very much. Okay, so awesome lesson today. Very important. This is how we decide what type of factoring we're supposed to do if we are given a random factoring question. So we're going to go over very quickly the types of factoring that we have done, and then I'm going to stop, and then I'm going to do a different video, and I'm going to randomly choose questions out of a pile that I've made, and we're going to decide what kind of factoring we should do, if they're even factorable, because there's one in there that isn't. Okay, so let's start off. Very first thing you have to be able to do is get a common factor. So, and I got a green one here. This is a great common factoring question. What can we take out of 14x cubed plus 6x squared y minus 2x? Okay, hopefully you'll see it's a 2x. So you're going to divide the 2x out, and if you need to, you can write a little 2x underneath each of these terms, and it'll help you get the right answer. So we're going to end up, if I divide the 14x cubed by 2x, we're going to leave that with 7x squared. We're going to end up with a 3xy, and this is a trick one. I got to make sure you remember when you divide that, they don't cancel out completely. They leave you with the 1, okay? Again, if you want to pause this and write the questions down before I get onto it, I guess I should have said that earlier. All right, grouping, really nice. Oh, I should state, common factoring, you're always going to look for a common factor, but today's lesson, we aren't going to do common factoring and then factor again. We're going to leave that till Friday where we mix them all up. Okay, grouping, really obvious, 4 terms, okay? So you look at the first 2 terms and the last 2 terms and you try and take out a common factor. So in this one, we have an 8 and it leaves me with p minus y. And if I take out an x, I'm left with a p minus y. If the same bracket twice, it goes to the front. Yay, okay. Simple trinomials. It's a fan favorite. There is no number, or the number is 1 in front of this. I've put one in that has 2 variables just to show you that they can have more than 1 variable. In this case, you're looking for 2 numbers that multiply to 6 and add to -5. And this is a tricky combination because it can be 2 and 3, or it can be 6 and 1. So in this case, in order to have a positive and add to a negative, I'm going to end up with 2 negatives. So it's going to be a minus 3b, a minus 2b, and we're done. Again, all of these guys, just again, proof it how great my hair looks now, and it hasn't been cut in well over a month. A squared minus 2ab minus 3ab is going to give us that center term, and then the last 2 terms. So expand. If you want to check your answers and you have time, just expand. Okay, this one is the doozy, okay? We'll actually try and do this one last when we get to actually a random question, because it's the last one you really want to try. So this is the one where, again, you're going to check this, but it's not going to be in this lesson today. Can you take out a common factor? No, there's nothing common. So this is where we multiply 4 and 15, and I'll do it over here. So 4 times 15 is 60, and so it has to multiply 2 numbers that multiply to 60 and add to 16. And if you want to put a little multiplication and addition sign there. And nice question, in this case it is 10 and 6. So a lot of people were doing the decomposition, so that's where they would do the 4m squared plus 10m plus 6m plus 15, and then take the common factor of the first 2 and the last 2. The other way I was showing it, and I don't know how bright this is going to show up, that's not bad, was to take that first number and put it underneath each of these and reduce to lowest terms. Okay, and you will end up, final answer, I don't know which way you're going to do it, but I didn't really leave enough room for decomposition because I don't have a lot of the board space. you would end up with 2m plus 5 and 2m plus 3, okay? So again, either way is fine. Perfect squares, really you're looking to see, first of all, can you divide that 9 out? You can't. And then you notice that this is a perfect square and this is a perfect square. And if you're really gonna be on the ball, you would check the middle term by realizing the square root of 9 is 3, the square root of 16 is 4, 3 times 4 is 12, and if you double that, you get 24. Again, I don't think it's necessary to do that. What I used to do was just write 3x and 4 and 3x and 4, and I put my signs in there and I would check. 9x squared minus 12x works, okay? Minus 4 times minus 4 is 16. So then you're supposed to write this like that, okay? I should be putting equal signs. I'm not going to take off marks if you do this. All right, and the very last one, and I have to say, by far, Mrs. C's very favorite kind of factoring are difference of squares. You're only going to have 2 terms, they're both going to be perfect squares, and there's a negative in the middle, okay? And they're awesome. You put the square root, I guess I should have left room there for that, square root of the first term at the front, the square root of the back term at the back, and then you put a plus and a minus, okay? So those are the types of factoring I have slowly been trying to teach to you. Now, pause if you are wanting to go back over any of those individually, okay? But now what we're gonna do is we're gonna talk about how you would approach almost like a step-by-step plan on how to, it's like a flow chart, that's what we call it, factoring flow chart. So step 1, and I'm gonna get a nice new, where's my colors? I'm gonna go with a nice blue here. All right, step 1, always look for a common factor. Okay, this is gonna, common factor. Not only is it going to make your life a lot easier because it makes the numbers smaller to deal with, but it's wrong if you don't take the common factor out and it's there, okay? So step 1 is always common factor, okay? Hopefully, very straightforward. Step 2, this is where you count the number of terms you have in your polynomial. Okay. Now, again, if you want to look back at your notes, if there are only, I guess I could do this in a nice bright color. Man, oh, there we go. I am learning to be a little less picky about how perfect I am on these videos. So number 1, if there are 2 terms, okay, and it is still factorable, you're not just taking out a common factor, the only thing you can do with that is a difference of squares. Okay, so that's like the last type of question that we just did. So a really basic one might be something like, let's see, x squared minus 81, okay? There's your difference of squares. Very easy to tell that it's a difference of squares because there's only 2 terms, they're both perfect squares, and there's a minus in the middle, okay? If you have 4 terms, the only possible thing that you could do with that would be grouping. And again, that's an example we just did of that one. I'll just rewrite it again. Actually, I'll do something like 7x plus 7y minus 2x minus 2y. And you're going to group the terms and, well, you know how to do that. So first you common factor, then you count the number of terms. If there's 2 terms or 4 terms, this is what you're going to try to do. It may not be possible. It may not be further factorable. But 3 terms, This is where it gets interesting, okay? So, again, I'm gonna go, maybe I'll use this color again. Okay, so if the A term is equal to 1, so what that means is if the first letter doesn't have a number in front of it, okay? It is a simple trinomial, x squared plus, let's see, 2x minus 35, okay? This is a value of 1 here, and this is the one where all you do is you try and figure out what adds to 2 and multiplies to negative 35, okay? It's going to be 7 and 5, okay? So that is if you have a simple trinomial. If, and I'm going to go this way, if A and C are perfect squares, all right, chances are it's a perfect square, okay? I am not going to give you questions, I mean I could, but I'm not going to, where they are not a very nice middle term, okay? So I'm trying to think of, now see, whoops, I've got an example sitting here. Where have we got one? Okay. Oh. I don't know if I have any. So let's just make this up. 4x squared, and let's say we put 9 at the back of it, times 3 is 612. Okay. There you go. So, perfect square, and if I do the actual factoring, I'll find out that the middle term is going to add up to 12. Okay, so that's where you want to go. You want to go in this exact order because the very last thing you want to have to do is deal with if A is not equal to 1 and it's not a perfect square. And this brings us to the complex, okay? And that's the one where you either have to use the cross method or decomposition, okay? All right, and an example of that, what's a really nice, they're like I said, they're the last thing you want to end up doing. So let's see, here's a good one. I'll do it in the right color. 6x squared minus x minus 15, okay? So, the 6, can't factor the 6 out. 6 and 15 are not perfect squares, so the only option is to try to use the cross method or decomposition. Okay, so once you've got that down, I want you to stop. I want to make sure you understand everything you're doing. And I'm going to stop this video and I'm going to come back at you with video 2, in which case I have a whole bunch of random questions that we are going to quickly see if we can identify and factor. And if you can do that, then you are so ready for factoring in grade 11. You're ahead in most. Okay, great.